Today's lesson is factoring out the greatest common factor, or the GCF. There are four lessons or four topics we want to discuss in this lesson. First, factoring out the greatest common factor of a polynomial, factoring completely, factoring out the opposite of the greatest common factor, and factor a polynomial by grouping. Only one vocabulary word in this section, and that is greatest common factor. It's going to be important to understand the greatest common factor because when you're factoring polynomials, in order to factor correctly and completely, you want to always try to factor out the greatest common factor. Now, if you factor out a common factor, that'll be okay, but you might have to continuously factor until you actually factor completely. So, the greatest common factor. The greatest common factor of two or more terms is the monomial with the largest coefficient and the highest degree that is a factor of all of the terms. So, for example, if we look at these three terms here, 7x squared, 14xy, and 35x to the third. If I look at the coefficients, there is a 7 in common with each coefficient. This is 7 times 1, 7 times 2, 7 times 5. So I can factor out a numeric term of 7. Now looking at my x's, I have x squared, xy, and x to the third. I can factor an x out of each one of these terms. So my greatest common factor would be the 7 and the x, or just 7x. Now it's important to understand and remember that multiplying and factoring are inverse operations. So if you remember from an earlier lesson, we talked about the distributive property, where we distribute 5x to the binomial or whatever's inside our parentheses. In this case, 5x times 2x plus 5x times 3, and we got this answer. What factoring does is factoring takes this answer and brings it back to this form. So I have, in this case, two things being multiplied together. So let's try to factor these. I'll factor the first one, and then I want you to pause the video and try to factor the second one. First, looking at the numbers, 14 and 35. I can factor a 7 out of 14 and a 7 out of 35. Looking at the x squared and the x, well, I can factor an x out of each one of those terms. So the greatest common factor would be 7x. Now, once I factor out the 7x from each of these terms, what's left? And the way you figure that out is you do 14x squared divided by 7x. That leaves me with 2x. And 35x divided by 7x leaves me with 5. And so what's left over is 2x minus 5. Now please pause the video and try to factor out the greatest common factor, and then also insert what goes inside the parentheses as well. Okay, so we factored out a 4 from the coefficients and an x squared from the x terms, or from the x factors. So 4x squared is my greatest common factor. Now, to figure out what goes inside the parentheses, I want to divide 8x to the third divided by 4x squared, that goes here, plus 12x squared divided by 4x squared, 2x plus 3. Now let's factor some polynomials by factoring out the greatest common factor. Please pause the video and try to factor Okay. The greatest common factor in this case is 10x squared. Looking at the coefficients, this is 10 times 2, and this term is 10 times 5, so 10 is in common. This one is x squared times x, and this is x squared times 1. So my greatest common factor is 10x squared. And then when I factor out a 10x squared, I am left with 2x and 5. So this one works exactly the same way, just a little longer. Let's first focus on our coefficients. This is 14 is 7 times 2, 21 is 7 times 3, and 70 is 7 times 10. So I can factor a 7 out of each one of these terms. If I look at my p factors, I can factor a p out of each one of these terms, and I can also factor a t out of each one of these terms. So my greatest common factor is 7pt. And notice my addition came down, my subtraction came down as well. And then what's left over goes in these slots. So 14 divided by 7, 2, p to the 4th divided by p is p to the 3rd, and t divided by t is 1. So this first term here will be 2 p to the 3rd. And then we do the same for the other terms, and we end up with this. Now factor by grouping. This is a different type of factoring. Factor by grouping, the first thing we want to do is convert all subtraction to addition, because parentheses do not change or alter the expression if you have all addition, but parentheses can alter if you have subtraction. So you want to first convert this to plus negative x and plus negative 2. And when I do that, if you notice, put my parentheses here, this was plus negative 2. I factored out a negative here. So if you look at this, it would be x to the 3rd plus 2x squared minus these two things, minus x and minus 2. That's important to understand that first. Now I'm going to factor by grouping. So I have two groups. If I look at my first group, I can factor an x squared out of each one of these terms. In this case, I can only factor out a 1. Do not say you factor out a 0. You can only factor out a 1 from these two. Next, if you look at this as being one big term and this as being one big term, I can now factor an x plus 2 out of this and an x plus 2 out of this, and then what's left behind is x squared minus 1. So in doing that, I factor out the x plus 2, and I'm left with x squared plus 1. Now, also, the way I like to teach this is your factors will always be the stuff inside the parentheses, which should be the same. That's one factor. The other factor will be what's left over, x squared minus 1. So one factor will be what's inside your parentheses. The other factor will be what's left over, x squared minus 1. Now, let's write an expression for the area of the shaded region of the square. Well, remember, the area of the shaded region is the green area. So if you know the formula for the area of a square, that is side squared. And if we know the area for a circle, which is pi times radius squared, what we want to do is we want to take the area of the square and subtract it from the area of, take the area of the circle and subtract it from the area of the square. So this is the area of the square. This is the area of the circle. And so I take this area of my square minus this area of my circle, or I should say this area of my circle. So the expression for the area of the shaded region would be this. Now if you notice, I can combine some like terms here. So the area of the shaded region is 30.96 x squared, units squared. Now let's write an expression for the length of the rectangle. The length of the rectangle. Well, the length we don't know, the width we know, and the area we know. Well, if you know the formula for the area of a rectangle, which is length times width, then we can say this unknown times 5x will equal this area. And then also, since you know that this unknown times this 5x equals the area, I could take the area and divide it by the length to get my width, or I can take this area divided by my width to get my length, and that's what we did here. So since we have a division problem, this is very similar to what we did in lesson 5.7. So I'm going to divide 15x to the fourth minus 30x and divide that by 5x. And then divide. So we have a length of 3x to the third minus 6 units. It's not square units, it's just units because length is linear. Please make sure you do the My Math Lab homework on 6.1. Thank you.